Probably just more of the lessons I have online.
Okay.
I'm just looking them up right now.
Okay.
I'm signing in. I'm just trying to evaluate like which lessons I got to do.
Mm-hmm.
I think I have like 4 that aren't done. I think.
Okay.
Let me look. I'm checking right now. Lessons. Yeah, we got them. Yeah, it's about like 4. Let's see what's this one right here. Oops. Hold on, I'm just logging into everything. It takes a second.
No, that's fine.
Alright. Okay. Okay, let me look at the first one right here. So this one is question 1. I think this is one we did yesterday. Never mind. Sorry, I opened the same lesson.
It's all right.
Oops, let me go back again. This site is really weird sometimes. How about this one? Yeah, okay, here we go. Alright, so this one says determine visually whether the graph is symmetric with respect to the x-axis, y-axis, or the origin.
Okay.
And
I can't imagine how we're going to do that unless I can see a copy of the graph.
give me a second. Let me just do this real quick.
Okay.
Flip that around. Can you see?
Mm.
Oops, it's loading.
I might if I make you the presenter. You want me to make you the presenter?
I'm not on the computer. I can switch to the computer real quick. Probably make life easier.
When you said, can I see it, how am I supposed to see it?
Oh, let me see if you can see the screen now. Can you see my screen? Or the?
I have to make you the presenter for us to be looking at your screen.
Okay. Give me a second.
Oh, I could. Hold on. I just saw something.
Oh yeah, that's what I was going for. Let me do that again.
Webcam, and you were just showing me the picture. I saw it briefly, and then it just.
Yeah, here we go.
Okay. Yeah. All right. Hold it right there.
Okay.
Now, what determines symmetry is can you reflect it over one of the axes and have it be the same?
If that folded over, yes, it would be the same.
The x-axis.
On the x-axis, if it like folded over, no, they wouldn't. If that equation was on the other side of the x-axis, right?
Here, let me bring this up just a second. All right. So I can draw it. Hold on one minute. So here's what we have. Correct?
Mm-hmm.
So for it to have symmetry, it has to look the same way.
Yeah, I got that.
Well, if you fold it over the x-axis, it looks exactly the same. So you definitely have symmetry with the x-axis. If you fold it over the y-axis, you would have this. Well, that's not the same.
Mm-hmm.
So it does not have symmetry over the y-axis.
But it does have symmetry,
symmetry with the origin. Basically, what that means is if you fold it over the x and the y, is it the same? And no, if I fold it over the y, I got this, and if I fold it over the x, I still got that. So you don't have symmetry with the origin. Let me draw an example of what symmetry of the origin would look like. Y equal x cubed. And that's supposed to go through the origin. Okay? Notice that if I reflect that over the y-axis, I get that. And then if I reflect that over the x-axis, excuse me, the first one was a reflection over the x-axis. And then if I reflect that over the y-axis, I get the same thing. So this cubic function is a reflection over the origin. Hold on 1 minute. I left my TV on. Let me go turn it off.
Okay.
All right. So, reflections about the origin can be figured out visually, but they can also be figured out algebraically.
Okay.
F of minus x equals, let me think for a moment. Let's see, if it equals f of x, then you have symmetry about the y-axis. If f of minus x equals minus f of x, then you have symmetry about the origin. So that would be x-axis, that's origin. Notice that y equal x cubed, I said, had symmetry about the origin. Well, if I plug in minus x for x, I get y equals minus f of x. I get y equal minus x cubed. So it satisfies that. And if I wanted to know whether something had symmetry with the y-axis, excuse me, I've labeled that wrong, then f of minus x has to be equal to f of x. And an example of that would be the cosine function. Well, or even, well, yeah, cosine function is actually a really good example of it. Notice that if I extend the cosine function in both directions, then f of minus x equals f of x. In other words, if I pick a point on the x-axis, that's what f of x is. If I pick the same point at negative x, it's the same value. In other words, the f of x value does not change whether I'm looking at minus x or positive x. And what this picture is symmetry about the y-axis.
Symmetry of the y-axis?
Uh-huh. This picture that I've just drawn, the cosine function, that's y equal cosine of x. If I flip that over the y-axis, I've got that.
What?
All right. What else you got?
Let me look.
Now, hold on. Let's go back just a moment and look at that one again. So that clearly has symmetry only over the x-axis. Doesn't have
Yes.
symmetry over the y-axis. If I flip that over the y-axis, it looks completely different. And it doesn't have symmetry over the origin. If I flip it over the origin, it looks like that also, which is not the same thing. So it only has symmetry over the x-axis, and that's neither odd nor even, but it is symmetry over the x-axis.
Okay. Then I'm getting some other questions.
Okay. If you have other graphs, go ahead and put them up on that webcam and I'll take a look. It's pretty easy to figure out symmetry graphically.
Yeah, true. It's not any symmetry anymore.
Okay.
It's it looks like graphing circles.
Okay, we can do that. Give me the equation of the circle.
X squared plus y squared equals 22. And it's like a multiple choice for the circle answer.
Tell me what the general format of the equation of a circle is.
The general format? What do you mean by that?
I mean this.
H minus x squared.
This is the general format of any circle, where h and k are the center of the circle, and r is the radius. So if I apply this general formula to the one you gave me, what's h and k?
H and k, is that x and...
No, in other words,
okay.
we didn't have an x minus anything squared. We had an x squared. So h is 0 and k is 0. Now tell me what r is.
That'd be 0 too?
That's r squared.
So 22 squared?
Square root of 22.
Okay.
So if I was going to graph that circle, I know that it's at the origin, and it has a radius of square root of 22. So that's what that point is.
Okay.
You always want to memorize these general formulas. There's almost nothing in math more important than knowing the general formula. Because if you can start out writing the general formula on a problem, well then you can do most any problem regarding circles. But you got to know what the general equation of a circle is. All right, what else do you have?
I'm looking. So we have x squared plus y squared minus 2x plus 4y equals 31.
X squared plus y squared minus 2x. What's the rest of it?
Plus 4y equals 31.
All right. What we have to do is to put that in the general format equation. And then we'll know everything there is. There's not much to know about circles. There's only two things that are interesting about circles, and that's where the center is and what its radius is. Everything else is automatic after that. Okay? Now, what they've given us here is not in this format, and we're going to have to complete the square to get it into this format. Once we get it into this format, we'll know where its center is, h comma k, and we'll know what its radius is. Now, if I want to complete the square on the left side, what's my next step?
You have to show what the values equal.
You have to gather like terms.
Okay.
I gathered the x terms, and I've left room to complete the square. And then I've gathered the y terms and left room to complete the square. And that's equal to 31. Now, the key thing to remember when you're completing the square is as you go from one row to the second, never change the equation. We have exactly the same equation, do we not?
We have the same one.
Okay, now let's complete the square inside the parentheses. Always making sure that as we complete the square, we do not change the equation. So how do I complete the square inside the x, the left parenthesis?
The x?
Mm-hmm.
So I don't know, so it has, I don't understand like how to complete it though. That's what I don't get.
Half of the coefficient of the x and square. Well, half of 2 is 1. It's always added. So that's how I completed the square. But notice I just changed everything. I just added 1. So if I want to balance out the right side, I got to add 1 over there. Now I have not changed it. In other words, what I have written here is the same as the original formula. Now,
Okay.
now complete the square on the y term. Do the same process.
Would we just plus 1 again?
No, you take half the coefficient of the term that's not squared and square.
So 2.
Squared.
4.
And again, I just added 4 to the left side of the equation. I've got to add 4 to the right. Now, the whole point of completing the square is so you can write it as a binomial square. That's what the general format is. Is this a binomial? Because I completed the square, I can automatically write that always as a binomial squared. And I can do the same thing with the y. What would the y term be?
As a binomial square?
Yeah. In other words, if
Okay.
I'm trying to put it into y minus k, quantity squared, what is it? It's y plus 2. In other words, this plus 2 is always what you got when you took half of that coefficient. Or this minus 1 is always what you got when you took half of that coefficient. And on the other side, I add up those three numbers and I get 36. Now,
Okay.
I've got it in the exact format that I need it in. I have it in x minus h squared plus y minus k squared equals r squared. So tell me what h, k, and r is. And that's, like I said, the only things that are important about a circle. The only thing you'll ever need to know is
Just do h and
center
k
and what's its radius. So where's h?
Is it 0?
That's h.
Okay.
Well,
1?
exactly. Positive 1. What's k?
Negative 2, or positive 2?
Negative 2. You were correct. It's y minus k. Since I'm looking at a y plus 2, k has to be negative 2. Because it's really y minus a negative 2, which gives you y plus 2. And what's r?
36.
And that's r squared.
So it would be, I'm trying to think of the square. So it would be the square root of 36, right?
Yep.
Which is 6.
Okay. Now I can graph that circle. I know exactly where it's at. I know its center is right here. And I know its radius is 6. Like I said, that's the only things you need to know. So completing the square is done when you want to take this x squared minus 2x and put it in the format of x minus h squared? Well, the way you do that is by completing the square. Completing the square is a big subject. That's an hour all by itself because you have to use it in numerous cases. In this case, we're using it for a circle, but we can also use it for an ellipse. We can use it for a hyperbola. We can use it to put a quadratic into vertex format. So there's all kinds of uses for completing the square.
Okay. Do you have another session after this?
I do. Unfortunately, I am stacked up today, solid.
Okay. All right, hold on. Let me look at what else I got.
I mean solid through 8.
Through 8 today?
I have time after 8 if you want more time today.
Maybe. That's not really what I was thinking, but I think we're all right. Hold on. We might have to cut it off a little bit early today if that's all right with you.
That's fine.
I hope that doesn't impede anything.
No problem with that.
We'll stop at we'll see where we are at 3, at 3:30, and maybe we have to go a little bit longer. I don't know.
Okay.
Just give me a second. Looking at other stuff. Yeah, let me look at this.
Now let me just give you a quick test.
Okay.
Complete the square.
Would it be, you'd take out 4, right? And then square it?
Take out 4. You cut that in half, that coefficient.
And then you square it, right?
And then you square it and you always add it. And since I have
so we get
16 to the
plus
left
16.
side, what do I have to add to the right?
16.
Now how can I rewrite the left? I want to write it like this. That's the whole reason I completed the square, is so that I can write it as a binomial term squared. What goes after the plus?
Oh, you get y minus x, right?
No.
So,
hold on. What goes after the plus is a 4. In other words, it's x plus 4 squared that's equal to this quadratic.
okay.
Whether those are exactly the same. That's the reason I completed the square. That's why you do it, is so that you can write this term here as a binomial linear term squared.
Yeah, that makes sense.
Always. That's what the reason you're doing it.
Alrighty.
All right? All right. What else you got?
Let me look. So we have 6 over x plus 5 equals 8 over x.
8 over x?
Mm-hmm.
What's the first step when I have a fraction equals another fraction?
Cross multiply, right?
Yep. Simplify by distributing the 8. Now what?
And then you, would you take this divide by 6 on both sides?
No, you gotta gather all of your like terms on one side and all the numbers on the other.
So you would subtract 8 then? 8x on both sides?
Okay, that'll give me minus 2x equals 40.
And then you divide by negative 2.
Minus 20. Now, let me just say something about that. You subtracted 8x from both sides. I would have subtracted 6x from both sides. The reason is that I want my variable to have a positive coefficient.
Okay.
I would have ended up with minus 40, because then I would have had to take it on the other side, equals 2x. So I get the same answer, as you always will. The only difference is that when I did it your way, I had a negative 2 there. When I did it my way, I had a positive 2. And that's
Okay.
always the decision that I use as to which side to move the variable to. In other words, when you're solving an equation like that, the very first decision you have to make is which side do I put my x's on, which side do I put my numbers on? Well, make that decision based on what will the coefficient of the x term be. If I move the 6x to the right, it's going to be positive. If I move the 8x to the left, it's going to be negative. So I'm going to move my 6x to the right.
Okay. I think I got that.
And that's just a standard rule that I kind of follow. It's not necessary. You can do it either way, as long as you're good with negative numbers. But what I've found is that most people, that's when they make mistakes, is when confronted with negative numbers.
Yeah, that's true. Okay. Yeah, I think that's all for now. I kind of have to bounce early, unfortunately.
Okay, no problem.
Thank you.
If you need more time, like I said, I'm available at 8.
Okay. Thank you. I appreciate it.
You're welcome. Talk to you later,
All
man.
right, bye.
Bye-bye.